Section 3.2 is on linear and quadratic functions. Just some definitions here. A linear function is a polynomial function of degree 0 or 1. Degree 0 means that there's no independent variable at all. Degree 1 means that the highest power on x is a 1 on the, assuming x is the input. Okay. In the Cartesian plane, that's the real plane, the linear functions can be written as f of x equals mx plus b. So you've all seen this before, I'm sure. So these are the linear functions. This is the equation of a non-vertical line with slope m and y-intercept b. Okay, the vertical lines you can't write this way, because remember f of x is y usually, and the vertical ones would be x equals some constant. So you can't have y equal to when you have x equals some constant and there's no y's in the equation, right? If m equals 0, the line is a horizontal line, and you just have, and the linear function f of x equals b is a constant function. That's what we call it, a constant function. So that's a degree 0 polynomial. That's still considered a linear function, though. That's a degree 0. Okay, here's a few notes. First, the vertical line x equals d, the vertical lines x equals d for different values of d are not functions of x, so they are not linear functions of x. Think about the vertical line test. It fails the vertical line test miserably. A vertical line does, right? A vertical line intersects the line in more than one point, so it's definitely not a function. In higher dimensions, the graphs of linear functions are not lines. So n dimensions means n variables. And by that I mean, n variables, right. So in 3 dimensions, you'd have something like this. F of xy equals 2x minus 3y plus 1. It's a linear equation of a plane in 3-dimensional space. Right? So that'd be x and y. And then the f of xy they usually call z. So you have x, y, z, 3 dimensions. And that's the equation of a plane. But it's still called the linear equation. So they just give flat things. In fact, in higher dimensions, 4, 5, 6, they call these flats.